All right, I wanted to go over real quick the calculations in the report um, for your in-lab experiment. So down at the bottom of your experimental pages, it says for your report to be uploaded in the Canvas and graded, please complete the following steps 1 through 8. So you see for number 1 here, it says use the mass of each of the 3 samples of sodium oxalate. So you're going to have some grams of sodium oxalate, and you're going to have 3 of them, and you're going to need to use that along with the volume titrated. So it's 1, 2, 3. You have the volume of uh, of not NaOH, it's sorry, potassium permanganate. 1, 2, 3. So those are the experimental parameters that you have, and you're gonna need to calculate from that the concentration of the potassium permanganate. So what we need to do is we need to take the grams in each case and convert that to moles. So I need the molar mass of this, and you can calculate that grams per mole. Then I have the moles of the sodium oxalate, and I want to find out how many moles of the potassium permanganate must have been there to react with it for each one of the titrations. So I'm going to do this for each titration. And I have the moles of this sodium oxalate, and I know that reacts in a 5:2 ratio with the potassium permanganate. So now I got the moles of potassium permanganate, and all I need to do is divide that by the volume that I titrated in 1 here in liters. So I have to make sure in liters, and then that'll give me the molarity of the potassium permanganate. I do that 3 times. Then in number 2, I just take the average of those 3 that I calculated. Then we see here, number 3, using the average molarity of the potassium permanganate that we just calculated from the standardization. Determine the moles and the grams of oxalate in each of the 3 titrated green crystal samples. So in order to do that, I'm going to use the molarity average of the potassium permanganate that I just calculated above. I'm going to times that by the volumes of 1, 2, and 3 samples of the potassium permanganate that I titrated into those samples. And that's going to give me the moles of potassium permanganate. And now I want to use that 2:5 ratio again to get the moles of oxalate that must have been in there. And then once I get the moles of oxalate, I'm just going to multiply that by the molar mass of the oxalate. And you can figure that out. And that's going to give me the grams in each one of those samples that I titrated for the content of oxalate. Now it says using the mass of crystals, that's the green crystals weighed for each trial. use equation 10 to determine the percent by mass of oxalate in each sample. So I have the grams for each one of those determinations of the oxalate. So all I need to do is divide that by the samples of green crystals that were analyzed in each 3 case, and then I times that by 100, and that's going to give me the percent oxalate 3 times. So that's, I think, a pretty good hint towards how to accomplish number 4. Now calculate an average of the oxalate, calculate average and relative standard deviations. So you know how to calculate the average, and then it asks you to calculate the average and the relative standard deviations. So you can do that according to those formulas that you've done before. Then it says for number 6, calculate the percent oxalate based off of the true structure. And then it gives you an example with water. So you're going to need to add up all the grams per moles for everything in this formula. And also don't forget to add in 3 times the molar mass of water. And then that'll be the total molar mass of the green crystal. So that's molar mass of the green crystal. That goes down here, and that is made from adding up all the atomic masses, just like you would for any compound, for all the different atoms in that green crystal. And then you'd have to add in 3 times 18, which is the molar mass of water. You don't multiply it. This dot over here means that it's coordinated into the green crystal. And that means it's just that there's 3 waters trapped in there. And so you want to figure out what that total is. That would be the total. And then you just want to divide that into 3 times the molar mass of the oxalate, because there's 3 oxalates in that structure. And then you times that by 100, and then you get your answer. I think it's, I don't remember, it's like 54%, somewhere in that area that you should get. And that's the true percent oxalate given the formula. And that's what you're going to compare for your error analysis. All right, then 7, it says summarize your results in a table that includes the calculated average for the molarity. So you want to put in all your molarities of KMNO4 and the average. You want to put in all the experimental percent of oxalate. This has to be, in the upper position there. So you want to put in those values for the permanganate, the oxalate, and their averages. And you want to do a precision analysis. So put those values for the standard deviation in there. And you could put in the average standard deviation or just the standard deviation, because either one is a measure of the precision for each of the 3 values. Then you're going to calculate a percent error. And so that's different from precision. This is dealing with accuracy now, percent error. So you have to compare to the true structure. So you take the true value as this concentration for KMNO4 and you compare it to your average concentration, and you can get a percent error. For the oxalate, you're going to assume that this up here was the true percent, and so you can do a percent error for what percent you calculated for oxalate up here in this section. Okay, so you're going to get an idea of the precision by talking about, or at least presenting in your table, the standard deviation or the percent relative standard deviation. That has to do with how many digits you can repeat from one experiment to the next, and that talks to precision. Whereas the accuracy is addressed by talking about a percent error calculation. So accuracy is how different your values are for the average concentration of permanganate, and how different your values are for the average percent oxalate as compared to that one that you'd calculate with a true structure, and as compared to this concentration here that you're given as the true concentration for the percent error. All right, and the last thing that you need to do is write a discussion that includes restating the purpose and that you completed it. The purpose of the lab was to calculate the percent oxalate of, percent oxalate in this green crystal that you were given to analyze, and that's what you did. And then it says discuss the accuracy and the precision. So you're going to go back to that table and you're going to look at those values for error in the calculation of not only the molarity of KMNO4, but also the percent oxalate that you calculated to be present in those green crystal samples. And you're going to do that and talk about it in words. So that table, you should use that table above in order to finish your discussion and complete the assignment for number 8. And that's pretty much it. So I think it's straightforward, and you should be able to handle the rest, I think. If not, as always, please post questions.